Active learning for object detection and segmentation. Active learning is a technique that allows an algorithm to select the most informative and valuable samples from a large pool of unlabeled data for annotation. In the domain of object detection and segmentation, active learning plays a crucial role in training accurate and efficient models. In this part of the tutorial, we will explore various active learning techniques specifically tailored for object detection and segmentation tasks. 1. Uncertainty sampling. Uncertainty sampling is a widely used active learning technique that focuses on selecting samples that are difficult to classify or segment. This is achieved by measuring the uncertainty of the model's predictions for each sample. Common uncertainty measures include entropy, margin sampling, and least confidence. By annotating these uncertain samples, the model can improve its performance by focusing on challenging instances during training. 2. Query by committee. Query by committee is an active learning method that involves training multiple models with different initializations or architectures. These models form a committee that collectively makes decisions on which samples to annotate. The disagreement between the committee members' predictions serves as an indication of uncertainty, and the samples with high disagreement are selected for annotation. The advantage of this approach is its ability to capture different perspectives and generalizations of the models, leading to more diverse and informative annotations. 3. Expected model change. Expected model change is an active learning technique that estimates the impact of annotating a particular sample on the model's performance. It measures the expected change in the model's predictions by introducing annotations for the selected sample. This approach aims to prioritize samples that are likely to have a significant impact on improving the model's accuracy or reducing uncertainty. By selecting samples that maximize the expected model change, the learning process becomes more efficient and effective. 4. Diversity sampling. Diversity sampling is an active learning strategy that aims to maximize the diversity of the annotated samples. Instead of selecting samples based on uncertainty or expected model change, this approach focuses on selecting samples that cover a wide range of variations within the dataset. It ensures that the model is exposed to different instances, thereby improving its generalization capabilities. Diversity sampling can be achieved through clustering, spanning tree algorithms, or other diversity metrics. 5. Active learning with human in the loop. Active learning can benefit greatly from human expertise. In this approach, human annotators are actively involved in the process of selecting samples for annotation. This collaboration between humans and models helps in selecting samples that are challenging for the current model but relatively easier for humans to annotate. By leveraging human annotators' expertise, models can be trained on high-quality annotations, leading to improved object detection and segmentation performance. 6. Incremental active learning. Incremental active learning leverages the concept of iterative learning by updating the model and re-evaluating the samples to be annotated at each iteration. As the model learns from initially annotated samples, it becomes more accurate and confident, allowing it to select more difficult samples for annotation in subsequent iterations. This iterative process continues until the desired model performance is achieved. Incremental active learning aids in reducing annotation costs while achieving comparable or better performance compared to traditional active learning approaches. 8. Transfer learning for active learning. Transfer learning in active learning exploits knowledge learned from related tasks or pre-trained models on similar datasets. By leveraging pre-trained models, the active learning process can start with a model that already has a good understanding of the problem domain. This approach reduces the labeling effort by prioritizing samples that are less familiar to the model but still challenging. The transfer learning-based active learning approach accelerates the training process and helps achieve better results in object detection and segmentation tasks. Active learning techniques for object detection and segmentation provide a systematic approach to annotate data efficiently and effectively. By selecting the most informative samples for annotation, these techniques enhance the performance of models while significantly reducing annotation efforts and costs. Uncertainty sampling, query by committee, expected model change, diversity sampling, active learning with human in the loop, incremental active learning, and transfer learning are some of the key active learning techniques applicable to object detection and segmentation tasks. Incorporating these techniques into the training pipeline can lead to more accurate and robust models for real-world applications.